We're now to the point where, now that we know how to graph linear programming systems of constraints and find the feasible region, identify vertices, we know the mechanics of all of that. And now I want you to be able to take problems like this and come up with your own system of constraints. And so this is an application using a real-life example of how linear programming works. So we're going to be doing some word problems in this video. Okay, so this says to read with your partner. The intention was for you to partner up and work through this together, but time just did not allow it. So I'm going to work through this one with you, and then hopefully this will help you with the other problem that you are to do on your own. So let's see what we have here. We have this farmer, and the problem is giving us information about what he is growing, what he has to work with, both in terms of acreage and in terms of money. So let's jump over to what the ultimate questions are that we're supposed to answer. He's trying to grow corn and soybeans. So the first question we're supposed to answer is how many acres of each crop should be planted to maximize profit? So there are two different crops that we're supposed to identify in terms of how many acres should be planted. So we need a variable to represent each crop, okay? And you can choose whatever you want. I'm just going to go with x equals number of acres of corn, and y will be number of acres of soybeans. Okay, so that's always a first step. In these linear programming problems, you're going to be looking at two different items. The combination of those two items is what we're looking at, either to maximize profit, which is the case here, or to minimize cost in most cases. Okay, well the problem now says, or my little steps here, I'm trying to step you through this answer. So this is kind of like the routine that you'll go through when you solve these. Now that you've identified variables, we need to label the x and y axes for our graph. Okay, so my x-axis, I'm going to go to new screen, will be labeled as number of acres of corn. I'll just say corn acreage. And this will be, I'll abbreviate soybean acreage. Okay, very important step that we label the graph. Okay, so we've done these two. Now we're going to start coming up with our own system of constraints. Now remember, constraint means basically limitations, or what is it that we have to work with. And inequalities will be used to represent each of these word statements. So I've just lifted out this first sentence basically. This particular farmer has at most 500 acres with which to grow corn and soybeans. So you might think of it this way. If I combine corn and soybeans together in acreage, so X represents corn acreage, Y represents soybean acreage. If I put these two together, I can't go over 500 because 500 is all I have to work with. So the way to represent that inequality is X plus Y, corn and soybean acreage together, cannot exceed 500 acres. So that's my constraint for acreage. All right. Then we have another constraint based on how much money we have to spend. We only have, according to the problem, he's got $12,000. And Corn costs $20 an acre. Soybeans cost $30 an acre. So the way we would represent this inequality would be 20 times the number of corn acres, which we have identified as X, plus 30 times the soybean acreage, which we've called Y, cannot go over $12,000. So the way we say is limited to or cannot exceed is we'll say less than or equal to 12,000. All right, so we've got two constraints based on what we're told. All right, and let's just move on to the next screen. Letter E, what additional constraints must be satisfied? And what this means is we're not going to make a negative amount, or we're not going to plant a negative acreage of corn or a negative acreage of soybeans. That probably makes sense to you. So what we typically do in cases like this, and you've already seen this in the linear programming problems that you've been graphing, we have these extra two inequalities, which basically mean that corn cannot be less than 0. It could be 0. We might decide not to plant any corn, but we're not going to plant negative acreage of corn. And that also applies to soybeans. So these are the final two inequalities in my system. So to put this into more familiar terms, on your last test, all of these were given to you. Okay, X plus Y is less than or equal to 500. And you were to graph that, all right? And then the other one, 20x plus 30y is less than or equal to 12,000. All right, and so it's looking familiar? All right, yeah, they were nice. It was nice last chapter on the last test. We just gave you all of this and we said graph it and identify the feasible region vertices and what maximizes the function. Well, in the next test, you're going to have to come up with this. Okay, so now we're going to go about our business of graphing this system, and I'm going to go through that with you. And obviously, we don't have a graph that goes up to 500 or 12,000. So on your paper, I meant to put this for you, but you can put your units in whatever you want. But I'm going to do units of 100 each. Okay, so for the x-axis, I'm going to say the x-axis is in 100s. And it's a good idea for these linear programming problems that whatever you do for the x-axis, you do the same thing for the y. So it makes it consistent. It's just less confusing. Okay, so let's begin. Let's start first of all by this with this inequality x plus y is less than or equal to 500. Well, we need to solve it for y, of course. And when we do, we have negative x plus 500. So once again, this is 100, 200, 300, 400, 500. Slope of negative 1. And then grab your straight edge. And this line will be red. And it looks like this. All right, now let's do the blue. 20x plus 30y. So once again, we need to solve it for y. So first step will be to subtract 20x from both sides. And then we're going to divide everything by 30 to solve for y. So I'll show that step. And we get y is less than or equal to negative 2/3 x, and this is going to be 400. By the way, since the numbers on these problems do tend to get larger, This next test will be your first one where you will be able to use a calculator. So don't worry about what do I do with this on a test. I mean, it should be easy enough, but I'm going to let you use a calculator next time. So 1, 2, 3, 400 is here. And then we're going to do a slope of negative 2/3 down to right 3, down to right 3. And let's draw this line. And that's the blue. All right, and then we have these other constraints, which are basically, in reality, we cannot make negative quantities. And so remember, x equals 0 is vertical right here. Y equals 0 is horizontal here. And now, don't forget, we got to do shading. So I'm just going to do all of my shading at once. For the red line, it's less than, so I'll be shading below. The blue line is also less than, which is below. And for the other two, the greens, they're both greater than, which is right and above. So what happens is our feasible region ends up being this area, the yellow. Okay, remember that's called the feasible region. And it's from the feasible region that we get vertices. So let's just list our vertices. The origin, 0, 0. We've got where red and green meet each other, 1, 2, 3, 4, 500, 0. We've got this blue and red intersection, which is 1, 2, 300, 200. And then up here where blue and green meet, 1, 2, 3, 400. So that's 0, 400. All right, so we've got our vertices. And so we've taken care of letter F, E and F. Okay, so we need a profit function. So if you're looking at your paper, you see the sentence that reads the profit on each crop. So profit function, I've already given you the P equals. You're making $50 per acre of corn. Corn is our X variable, 50X. And you're also making $65 per acre of soybeans. So that's going to be 65Y. So that answers letter G. Now, what combination of corn and soybeans should be used to maximize profit? Well, now you're going to test your vertices. Okay, so we're looking for the combination of X, corn, Y, soybeans, that would give us the highest value of P. Well, you can probably tell that's 0, 0 is not going to do it for us. For 500, 0, you're going to do 500 for X. That's 50 times 500. So you got 25,000. I'll just put the amount here. Okay, so for 300, 200, X is 300. And Y is 200. That's 28,000 for P. And then for 0, and then all we need to do is 65 times 400. And that's 26,000. Okay, so to answer our question, the combination that gives us the highest value for P is here, 300 acres of corn and 200 acres soybean. Oh, I'll just abbreviate SB. Okay, so that takes care of H. Now, what is that profit amount? Well, we figured it up here, and that's $28,000. Okay, so I wanted to give you step by step, and notice at the very bottom of your sheet, I didn't copy this over onto my slide, but at the very bottom for tomorrow, you need to go to the Chapter 3 test in your textbook. It's page 160, and problem number 14, I want to see if you can do that one on your own. And if you need graph paper, I've put some files on Moodle where you can print it off, and probably you just need one sheet, and I would probably stick with the larger size on these linear programming problems. I think it's a little bit easier. Okay, so again, this video was just to help you, guide you. I hope you don't just sit down and watch the whole thing and copy everything down and then go on. You should now, if you found yourself completely lost and not knowing what to do, now that you've seen this, see if you can go back and work this all the way through yourself. And then hopefully you'll be able to work the problem from your textbook yourself as well. So that is your linear programming example for this video. Now let's take a look at your other sheet, which deals with applications, real-life applications involving 3 variable systems. And I'm going to do the together problem because, again, some of the classes just did not have time to work together on this. So let me do this one for you, and the one you've got one in your book that's very, very similar. So if you follow this problem as a guide, I'll show you the problem in your book that is a lot like it. All right, so let's set up this problem. Hopefully you're going to read through this very carefully, but here's the gist. You have $3,200, and you've decided that you're going to invest all of it. You're going to split it up into 3 different funds. One's called a growth, an income, and a money market fund. Okay, so just in case you're not familiar with how investments work, the whole idea is for you to invest money, and if it's a good investment, then you're going to get your money back plus more money, which that plus more money we call interest. Okay, so that's always the reason for investing, is to take our money and hopefully let that money make us more money. Okay, so we've got 3 investments, and we've got some information here, and we'll come back to that in just a second. The bottom line question is that we're supposed to answer is, how should you invest this money, this $3,200, in order to get a total of $250 back? So you're going to get all of this back at the end of the year plus $250. So to make that happen, what is the combination of our investment of this $3,200 into these funds that will produce this interest amount? So to start with, we need 3 variables because there are 3 different funds that we're investing in. Now, your variables could be X, Y, and Z. I'm just going to stick with, so I can keep these funds straight, I'm going to call G the growth fund. Let's get a little more specific here. I'm going to say amount invested because that's what the problem is asking for. A little more writing, but it's really worth it to make sense of these variables. And then I stands for the amount invested in the income fund. And then, of course, M is the amount invested in the money market. Okay, so on your sheet, that's the first letter A that I've given you there, of course. That will always be your first step in these 3 variable system problems, is to identify the variables that will help you answer whatever question is being asked of you. Okay, now let's go to letter B. Now that we've identified the 3 variables, we need to write 3 equations. So anytime you have a 3 variable system, obviously you're going to need 3 equations. So I've just broken this out for you. I've taken these sentences, and it's from these sentences that we're going to write equations. So first of all, using our variables in an equation, how would we write an equation that represents the fact that we're going to invest this amount of money into some of this money into each of these funds? Well, remember the growth fund was G, the income fund was I, the money market fund was M. That represents how much I invested in each one of these funds. And those three investment amounts together should equal $3,200. So there's one of my three equations. Okay? Now let's look at this next sentence. It's going to give us a clue as to another equation that needs to be written. You decided to put twice as much money in the growth fund as the money market. So in other words, the growth fund should represent 2 times the money market. Okay, that's just another way of saying that phrase. Whatever we have in growth, it should be the same as double the money market. All right, so my equation here will be G, growth, amount invested in growth, will be double or 2 times, twice, the money market fund. Okay, there's another equation. Now here's my third one. The amount that you will earn total should equal $250. Well, remember, the whole idea of an investment is to earn money on our investment, and this sentence basically tells us how much we're going to earn on each investment. All right, so how would you represent earning 10% on the growth fund? Well, whatever you invested in growth times 10%. Okay, so 10% times the growth fund. Okay, now let's take a look at how much we're earning on the next fund. We're earning 7% on the income fund. Well, that's 7%. Remember, that's the decimal form of 7%, 0.07, times I, the amount that I invested in the income fund. 7% times that investment amount is how much I made. And then finally, we're told in a certain amount, 5% is what I'm going to make on the money market fund. So 5% times M. And remember, these return, we call this return on investment. This is how much I'm going to get back on my investment. And the goal is to get $250 total in interest. So each one of these return on investments combined, add them all up, and it should equal $250 according to the problem. Now at this point, some people would like, I'm not saying you have to do this, but when there's decimals involved, it's certainly okay if you would like to just work with non-decimal numbers, just regular integers. And to make that happen, it's easy enough. We're just going to need to move these decimals 2 places to the right, which means, in effect, you're going to be multiplying by 100. Okay, so this is an optional step, but for some people that don't like to work with decimals, here's an option. Just remember, whatever you do to one side of an equation, you must do to the other. So the effect of multiplying by 100 is to essentially just move the decimal 2 places to the right for each one of these. And that gives me 10G plus 7I plus 5M. And then don't forget, you got to multiply 250 times 100 also, which is 25,000. Okay, well now we're in pretty familiar territory because we've already been solving systems, but the problem has been, well, it wasn't a problem, but before we were just given the system and told to solve it. Well, today and tonight, you're going to come up with the system and then solve it. So once again, let me just write this in system form. we have G plus I plus M equals 3,200. That will be like equation number 1. G equals 2M will be number 2. And then here's our changed up 10G plus 7I plus 5M equals 25,000. And that is our system. And so now you get to decide. It doesn't matter to me which method you choose. I would say this, since we already have a variable solve for, here we have G is 2M. To me, substitution makes sense. All right. So what substitution says is solve for a variable. Well, that's already done for us. And then replace that variable in the other 2 equations. So in equations 1 and 3, I'm going to replace G with 2M. Okay, there's replacing it in equation 1, and then maybe over here we'll do a different color and replace it in equation 3. Okay, now simplify. 2M plus 1M is 3M plus I. All right, so over here, this is going to be 20M and then plus 5M. So let's just go ahead and combine those. 20 plus 5M is just 25M plus 7I is 25,000. Okay, and now you should remember what to do. We're going to put these two together and pick a variable to eliminate. So let's just go with green here. 3M plus I equals 3,200. And then 25M plus 7I is 25,000. Okay, well the easiest way I think is to eliminate I, but we're going to have to multiply the top equation by 7. So 7 times all of these, that would be 21M plus 7I and 3,200. Okay, so multiplying by 7 all the way across, 3,200 times 7 is 22,400. And then we didn't have to do anything to this bottom equation. All right, and eliminating I is going to require subtraction. So 21 minus 25 is negative 4M. The I's will eliminate. And then we have 22,400 minus 25,000. And that's negative 2,600. Dividing both sides by negative 4. And we got 650 is M, and M represents the amount we're going to invest in the money market. So I'll just put up here money market investment. $650. And I provided this answer for you at the bottom of your sheet. All right, so it looks like the next investment amount I'm going to get is the income. And I'm just going to go back to this equation, and I'm going to let M be replaced with 650. So 3 times 650 plus I is 3,200. So if you have your calculator handy, you can multiply that out. 650 times 3 is 1950. So to get I, or the income fund amount, we're going to do 3,200 minus 1950. And that's 1,250. So the income fund investment is $1,250, which matches your sheet. And then finally, we need to find out what the growth fund is. Growth fund investment. Well, that's easy enough. Going back to my original system, I already have a growth fund equation. Growth is equal to 2 times whatever M is. So 2 times M was $650, that's $1,300. All right, and so that's how we got those answers there printed at the bottom of your sheet. Okay, so what I want you to do, it says on the back of your sheet to work with a partner, you and your partner, but that if that did not happen in class, and for some classes it did not, I want you to work that problem on your own. But number 19 on page 153 is very similar to what we just did, okay? So if you'll go back and look at your notes here, they're very similar. They set up and solve very much the same. And then you see the on your own problem. So go over to page 153 and see if you can do that stadium seat problem number 20. So I just wanted to clear up. It says partner, but if you did not get a chance to do that in class today, that needs to be you. Look at the example here, and then the on your own problem there on page 153. So let me know if you need further help. You can see me in academic support, send me an email, and I'll be glad to help you.